on page 354, I'm going to be doing 24 through 26, and it says to use synthetic division and the remainder theorem to find P of A. Now over here on the right hand side, what I've done is I've taken the value of A and I've evaluated the expression by substituting in 3 for the value of x. And when I did, I came out with the answer of 93. The reason why I did that is because I want to show you how this relates to the remainder theorem. With synthetic division, we know that we must first prep the equation and make sure that it's in descending order, and if there are any gaps or holes, we need to fill those up with zeros. So I'm going to begin by removing the variables and just writing the coefficients. I am missing the constant, so I need to place a 0 in for that. The 3 goes inside the box. It's not a -3 because the value was not given as a factor, it was given as an actual value. So again, with synthetic division, we drop down the first term and start multiplying and adding. So we'll start with 3 times 1, and we'll add those together to get 4. 3 times 4, and we'll add these two together to get 11. 3 times 11, add those together, and 3 times 31 is 93. Add those together, and you get 93. Now, if we were going to put this back in variable notation, these would be the coefficients of that. We always start with 1 degree less. So in this case, the degree here is 4, so we're going to start here with 3, and we're going to do a countdown. So it's going to be 4x squared plus 11x plus 31, and you'll see that 93 happens to be the remainder, and that's how the remainder theorem got its name, was that this value right here, as you'll know, is the same value as what I get when I run the 3 through that and just use substitution. So that's kind of neat how that works. Let's take a look at number 25. It has some uniqueness about it. And the first thing is you'll see that it is completely out of order. And so we needed to rearrange these terms. We also noted that there are some values missing, so we had to mark those with zeros. And now we're kind of ready to work this through. Our answer will be -30, and again, I got that answer just simply by using substitution. But the remainder theorem does tend to, the synthetic division does tend to speed things up when you get comfortable with it. The evaluations are a little bit more simpler to do in your head than if you were to evaluate some of these longer equations. So the number that goes over here in the box is the number +2, once again, because it was given as a number, not a factor. So drop down your -1 and start multiplying. That gives us a -2. Add those two together. A 2 times a -2 is a -4. Add those two together. And a 2 times a -4 is -8. We'll add those together. 2 times -8 is a -16. And we'll add those together. And finally, 2 times 17 is -34. And -34 plus 4 is -30. Once again, you can see that the evaluation is equal to 30. And finally, number 26 has been, once again, we do have some issues to work through here. It is in descending order, but we are missing some values. So I will start by just rewriting this, placing the markers in for those missing values. We do have an x squared. We do not have an x. And there's our constant 1. As you can see, we're going to be running a -2 through this, and we should get the answer number 77. So again, remove the variables, and we're going to be putting a -2 inside this box and dropping down that first term and start our multiplication. 2 times -5 is -10. Add those together. -2 times -10 is a +20. Add those together. -2 times 19 is a -38. Add those together. And a -2 times a -38 is a 76. Add those together, 77. And you can see how the remainder theorem Once again, just kind of makes that a little bit quicker than doing all these evaluations. And that concludes this lesson.